3-Eye Atlas just did something no one expected. Last night, telescopes around the world recorded a sudden, precise shift in its trajectory. No jets, no dust, no measurable cause, nothing that any natural object should be able to do. This isn't just unusual, it's breaking all known physics. And if this pattern continues, scientists warn it could force us to rethink how interstellar objects move through space. The moment the data came in, an uneasy silence spread through the research teams. Two observatories, thousands of kilometers apart, captured the exact same directional change almost simultaneously. Normally, small deviations are dismissed, instrument noise, dust interference, or minor rotation. But this wasn't that. Both datasets aligned with stunning precision. The odds of coincidence? Astronomically low. For scientists staring at the numbers, the conclusion was simple and chilling. Something unusual is happening. Imagine tracking an object drifting silently through interstellar space for millions of kilometers, cold, inert, and invisible in most wavelengths. And then suddenly, it shifts its path with surgical smoothness, almost like it knows where it's going. Not a chaotic tumble, not a random swing, a controlled adjustment, tiny but unmistakable. That is exactly what Atlas just did. When researchers compared this new motion with previous anomalies, the mystery deepened. Atlas does not rotate like a typical comet or asteroid. Its surface barely reflects light. It releases no gas, no fragments, no infrared signature detectable from Earth. It seems passive, silent, and yet its motion looks deliberate, a contradiction that has scientists baffled and obsessed. The first natural explanation, outgassing, fails immediately. Comets produce jets when heated, pushing themselves slightly, but Atlas is far too cold. Even the smallest jet would leave detectable traces. Dust, heat, spectral shifts, none appeared. Surface temperature remains uniform. The object did not brighten. No dust trail, nothing that suggests natural propulsion. Next came gravitational theories. Perhaps an unseen microasteroid drifted nearby, subtly pulling it. But space in that region is exceptionally well mapped. Every measurable mass is accounted for. Nothing exists near the vector of the shift capable of exerting enough force. Even if a tiny, previously undetected rock drifted by, it would create a messy, irregular deviation, not the smooth, precise correction observed. With natural explanations failing one after another, researchers confronted a third, uncomfortable possibility: non-natural movement. Something external acting on Atlas, or something internal adjusting its path. Both ideas challenge conventional astronomy, yet the data stubbornly points in that direction. Some scientists immediately revisited Avi Loeb's work, suggesting that interstellar visitors like Oumuamua may have exhibited non-gravitational acceleration. At the time, many dismissed it as speculative, but Atlas repeats the pattern, only more extreme, precise, and harder to explain. Two anomalies, same type, only a few years apart. Coincidence? Highly unlikely. If Atlas's shift is caused by internal mass redistribution, like reaction wheels on spacecraft, it explains smooth motion and stable rotation. But for an interstellar object to adjust its own path this precisely, the question becomes unavoidable. Who or what built it? Other possibilities exist, though they remain controversial. One is microcurvature in space-time. Perhaps Atlas passed through a tiny warped region, a gravitational ripple left by unseen cosmic structures. Physics allows such curvature, but nothing like this has ever been observed in such a low-density region. If true, space-time itself has structure we completely missed. The implications are enormous. Dark matter is another candidate. It carries mass but emits no radiation. If Atlas passed through a narrow filament, gravitational pull could alter its trajectory. But dark matter should produce smooth, continuous shifts, not sharp, timed corrections like those recorded. The precision looks intentional, not random. Every natural explanation falls short. Every attempt to fit Atlas into known physics collapses. That leaves two possibilities. Either something external is influencing it, or the object itself is responding internally. Either way, it challenges everything we know about interstellar motion. The next observation window is critical. If Atlas repeats this shift, a clear pattern will emerge. Patterns mean repetition. Repetition implies intention. Nature rarely produces such controlled sequences in anomalies of this type. Some astronomers are already preparing for this possibility, reviewing all previous interstellar visitor data for subtle deviations once dismissed as noise. They're modeling forces that could produce smooth adjustments. Behind closed doors, the word controlled is whispered more than ever. Atlas continues its silent journey, unchanged in appearance, but moving in a way that defies expectations. Each reading pushes the scientific community to a crossroads. Either new physical structures exist near the solar system, or something intelligent is influencing this object. Neither conclusion is easy to accept. Neither fits neatly within standard models. Even the data itself teases researchers. Minor trajectory corrections hint at repetition, slight adjustments consistent enough to raise eyebrows. If the pattern continues, Atlas may become the most important object humanity has ever observed, not because it's dangerous, but because it may be the first interstellar object demonstrating signs of control. Observatories around the globe are trained on it. Every new measurement brings more questions than answers. Is it navigating, reacting to an invisible field, or revealing physics we've never measured? The evidence is tantalizing but incomplete. Scientists are confronting uncertainties once thought to belong to science fiction. Rhetorical question: could this mean intelligent influence, or is space itself hiding forces we cannot detect? What if Atlas is the first messenger of something we've never encountered before? These questions hang in the air, unanswered. Whatever the explanation, one fact is undeniable. Atlas is rewriting our understanding of interstellar motion. It no longer behaves like a natural visitor. If its trajectory continues showing controlled corrections, we may finally witness the first evidence of guidance across the galaxy, whether through new physics, unseen cosmic structures, or some form of influence we cannot yet explain. For now, Atlas drifts deeper into space, silent, cold, and full of questions. Each new shift makes one thing clear: the universe is far more dynamic, mysterious, and stranger than anyone imagined. Scientists once believed interstellar objects were simple relics of other solar systems. They were wrong. Atlas shows that interstellar space may host phenomena that defy prediction, challenge assumptions, and blur the line between natural and unexplained. In the end, whether Atlas is ultimately explained by new physics or something altogether different, its behavior has already changed the conversation. Scientists are watching, recalibrating, questioning assumptions, and preparing for the possibility that the universe is far more complex than previously believed. And if the next shift confirms the pattern, Atlas may not just be an anomaly. It may be the first signal that we are only beginning to understand the true nature of the cosmos.